to the Sentic Labcast. Today I'm going to introduce my research paper, BiERU, which is the bidirectional emotional recurrent unit for conversational sim analysis. Conversational sim analysis is an important topic for developing Empathetic Chatbot. So for example, here is a conversation snippet, and the speaker says, "I finally got promoted today at work." So the speaker feels proud. And in the previous dialogue system, the response would be, "Why would anyone promote you?" So this response is inappropriate in this situation. And if we incorporate the emotion proud into the context encoder of the dialogue system, then we can get an empathetic response, which is "Congrats, that's great." So obviously, the Empathetic Chatbot achieves a better human-robot interaction since naturally we perceive and express emotion in natural language to increase our sense of social bonding. Here, the pre-trained emotion classifier is of vital importance. So now the question is how to get such a pre-trained emotion classifier. So before that, we need to give a clear definition of the conversational sim analysis task. The target of conversational sim analysis is to detect the emotion or sentiment which can be happy, sad, frustrated of each utterance in a conversation. And here the context information is the main difference between the conversational sim analysis and the single sentence sim analysis. The context information may sometimes enhances, weakens, or reverses the raw sentiment of an utterance. So for example, here is a conversation snippet. So for this utterance, I planned a hiking this week. So the emotion, it is hard to determine the emotion. It can be happy or neutral, but if we look through the previous utterances, then we can find that the speaker forgot the math test holding the next week. He will not have enough time to prepare for the test if he still carry out the plan of hiking. Okay, so in this case, we see that the emotion of this utterance is frustrated. And also the previous emotion state of a speaker is important for us to determine its current emotion state. For instance, if the female speaker does not tell the male speaker that they will have a math test, most likely according to his first utterance, the emotion state of this male speaker is happy. Okay, so now we are clear about this task. So the problem is how to classify the emotion of each utterance considering its context information. And here in this paper, our solution is that if we can incorporate the context information into the embeddings of the current utterance, then the problem becomes a normal sentiment analysis task. And in this case, we can use a high-quality classifier to classify the context-aware utterances. And the tools used in this solution are the generalized neural tensor networks and two-channel feature extractor. And then we'll briefly explain these two parts. So this is the neural tensor network. It is a good method to capture the relationships between two entities. And supposing these are the concatenation of the embeddings of context and current utterance. And by using the neural tensor slice, we can get a specific type of relationship between them. And if we apply k different slices, and then we finally got a k-dimensional embedding. And here we assume that this embedding is the embedding of the current utterance with the context information incorporated. And here is the two-channel feature extractor. So the motivation of this two-channel feature extractor is that the previous study demonstrated that the two-channel structure has a better performance than the single-channel structure. And now with these tools, we design a new model for the conversational sim analysis task. So here we denote the ERU as the combination of the generalized neural tensor block and the two-channel feature extractor. So if we use this ERU in a if this BiERU are combined in a recursive manner, then this is the global context version, this one. And in this variant, each utterance in the conversation has global context incorporated. And if we only employ the adjacent utterances, then it is the local context variant. So in this variant, only the adjacent utterances are regarded as the context of the current utterance. Okay, so now we have the new solution for this task. So the next step is to evaluate the effectiveness of the new model. So we conduct a number of experiments on the 3 benchmark datasets. The first one is the IMOCAP dataset. It is a dataset of 2-way conversations involved with 10 distinct participators, and it has 6 labels: happy, sad, neutral, angry, excited, and frustrated. And the second one is the AVEC dataset. So it contains interactions between human speakers and robots. And the last one is the MLD dataset. It is a multimodal and multi-speakers analysis dataset. So it has 7 statement classes. And here is the result on the 3 benchmark datasets. So the result indicates that this model, the BiERU model, is effective and gets the best performance compared with the baselines. And note that one interesting thing is that the local context version is slightly better than the global context version on the 3 datasets. And one possible reason is that the global context contains redundant information. Not all the previous utterances are related to the current utterance. And also, we analyze the efficiency of our BiERU model by comparing it with 2 strong baselines. And according to Figure A, our proposed BiERU model has advantages over the dialog RNN and dialog GCN model in terms of the training time. And in Figure B, it shows the training curve with the training and test loss plotted. We utilize the same loss function for all the compared models, and the results show our models have comparable convergence speed with their counterparts. And also, our model has less trainable parameters compared with the baselines. So in this case, we see that the BiERU model is a fast, compact, and also a parameter efficient framework. So to have an intuitive feeling of this task, we illustrate a conversation snippet. And in this snippet, person A is initially in a frustrated state, while person B acts as a listener in the beginning. Then the person A changes his or her focus and question person B on his or her job state. And the person B tries to use his or her own experience to help person A get rid of the frustrating state. So this snippet reveals that the sentiment of a speaker is relatively steady, and the interaction between speakers may change the sentiment of the speaker. So both the dialog RNN and dialog GCN models cannot successfully model the interaction between the 2 speakers in this snippet. And the 2 baselines are more likely to classify a few consecutive utterances into the same emotion label, which indicate that they are insensitive to the context information. And our proposed BiERU model, especially the local context version, have a strong ability to integrate the context information and thus get a better result. So to further explore our proposed BiERU model, we perform an ablation study on its 2 main components: the generalized neural tensor block and 2-channel feature extractor. According to this table, the performance of the sole GNTB and TFE is low in terms of the accuracy and F1 score. The reason is that the outputs of GNTB mainly contains context information, and the output of TFE lack context information. However, when these 2 modules are combined together, the accuracy and F1 score increase dramatically. So it indicates or proves the effectiveness of our BiERU model. Okay, so that's all for our BiERU paper. And here's the references. Thank you.